All right. Guys, welcome back. So today is day 14 of 200 days Python DSA series, and we will be talking more arrays. And today we're gonna solve two sum problem. What do you mean by two sum? Let me just give a brief idea. Okay. So whenever you add any two numbers, you get a sum, right? So that is called as the target here. Okay. So you have been given an array of integers, right? So this is the array. Okay. And you have been given a target. Now what you have to do is you have to return the indices of the numbers corresponding to whose sum is coming to equal to target, right? It means that you need to return the indices only, okay, not the number. Okay. Indices means the index of 2 is 0, index of 7 is 1, okay, index of 11 is 2, and index of 15 is 3. Okay, 0 1 2 3. Okay, so we just have to return the index, okay, or you can say indices of these two numbers. Okay, so one thing which is coming to my mind is we can use for loop, right? And we can actually traverse through for loops, traverse these this num through for loop, and we actually can get the ith and jth value, right? So that the target is achieved. That is the most brute force approach which we can think of. Okay. The other approach can be a different one, which we will be discussing. So first, let us start. Okay, let us see the constraint also. So the constraint is the num's length is equal to 10 to the power 4. So we can actually use the brute force approach with double nested for loop, right? That we can do. And nums of I, the value can be minus 10 to the power 9 to 10 to the power 9. So there can be negative integers as well. This is given. I mean, integers mean negative numbers. Okay, and the target can also be in the range of 10 to the power 9 to minus 10 to the power 9. Okay, so this is the thing which is given. Okay, now let us start with extreme brute force that we can use two pointers 0 to n. Okay, and we'll check the range of I whether it is up to 0 to n or less than n. Okay, first we'll define what is n. Okay, now so if I is at this position at 0, then we have to find the another number from here, so that will be taken care by the other loop. Now when I reaches this position, second last position, so the j will reach this position, and if I reaches the last position, then there is no place for j. Okay, So I would say j takes I plus 1 value, right? And I cannot be the last element, right? So I has to be up to n minus 1. So it means that n minus 1 means n is 4 and n minus 1 is 3, and 3 is not included. It means a 0, 1 and 2. So only up to second uh, index the I will traverse, right? That we can think of. Okay. Now let's consider a for loop. If nums of I plus nums of j, simple, is equal to target. If it is equal to target, then what I would return? I return I comma j. I just have to return the this thing, right? Let's check whether okay n is not associated with value length of nums. My bad. Yeah. So the test case is running. 3 and 3 target is 6. Test case is this 2, 7, 11, 15. So what is the target? Target is 9. It means that 2 plus 7. It means that index of 2 is 0. So it is 0. And index of 7 is 1. So 0 comma 1 is the answer. Okay. You can just try submitting this. I hope there is no TLE error. Okay. But the time which we are you know this runtime is lot, right? Now let us discuss what is time complexity. So here we are running one for loop, right? So its time complexity will be big O of n, right? And this is also big O of n. It is actually n minus 1, okay, and it will also be n minus 1. So it is, if n is larger, let's say if the value of n is bigger, here you can see the nums of length is 10 to the power 4. So if we think about the worst case scenario, then n takes the value of 10 to the power 4, and 10 to the power 4 minus 1 is nothing but 10 to the power 4 only. It means that there is a very little variation, or you can say it is approximately equal to order of n. So we can just write it as order of n here also and here also. Now you just see here, this is the nested for loop. Whenever there is a nested for loop, then the time complexity gets multiplied, right? So the total time complexity is equal to order of n square. Order of n square. This is the total time. What is the space complexity? We just have to have um, we just have to return a list which consists of two elements. So order of one. Okay. Means that it is a constant times constant space. Even if your number of elements is more than 10, 100,000, or nums of I is 10 to the power 9, then also it doesn't matter. We just have to return I and j, that's it. It means that our space complexity is always is a constant, right? It's always a constant. Okay. Now let us try to make it more optimized. Okay, so for making it more optimized, what we have to do is we just have to, you know, try to delete or try to remove this for loop. Okay, so that our time complexity comes in the level of order of n, right? So why, what do you think, which data structure uh, has the capability of reducing this to order of n? It means that if we want to have the other element traversing the other element, what is the best data structure where the order, uh, like you can pick it from, and mm, the order becomes order of 1 or constant. So that is the only thing, is the that data structure is the dictionary, right? That data structure is the dictionary. Okay, so let us try uh, doing start. We'll start with the for loop. Okay, and let us, in general, we take 0 to n. Okay, and now how I can use dictionary, I have to check in the dictionary whether that element exists or not. Okay, and if that element exists, then I'll have to return the index of that element. Okay, so that's the thing. So I just have to assume a dictionary also, my dict, or my dict equal to this. So dictionary will be a key value pair, right? It will be a key value pair. So now I want to find the num2, right? So num2, let us assume, is equal to target minus nums of I, right? It will be target minus nums of I. And if num2 is found in the dictionary, if num2 in my dict, right? Num2 in my dict, return, we don't have j, so we have to extract the j. So I just have to return I, comma, what is j? J will be the value, like key value. The j will be the value of that key. And what is the key? Dict of um, dict of num2. Yes. So my dict of num2, right? If the num2 is not in the dictionary, then uh, it should fill the dictionary, right? So my dict nums of I is equal to I. So here, as I increases, it will, put the indices in the value column. Okay, value position. Yes, getting executed. Yes. Now, so guys, you just see here, this is my J. Okay, this is my I, but this is my J. How I'm getting the J? I'm just calling, uh, I'm just calling the dictionary and calling the key. I'm getting the value. So my dict of key will fetch you the value. Okay, my dict of, so dictionary of key will fetch me the value, right? I am only interested in value, not in the key. My value will be this. I is my value. And what is I here? I at this position, it will be J. This I will be the, this command is creating my dictionary. Okay, this command is creating the dictionary with key value pair. So this is the key and this is the value, right? And this value we are calling here. This is the concept. Let's try submitting it. So now you can see the runtime. Initially we had approximately 1700 milliseconds of runtime. Now we are having only 0 millisecond of runtime. Okay, 100%. We are beating 100% people, right? So this is how uh, this is getting executed. So if you want to solve this, you can also use the hint given. So a really brute force way would be to search for all possible pair of numbers, but that would be too slow, right? So initially we did this. We have searched every possible value. Okay. Again, it's best to try out brute force solution just for completeness, right? It is from these brute force solution that you can come up with optimization, right? So whenever you find it key, okay, this is my brute force solution, it's taking a lot of time, 1700 milliseconds to execute, and its number of operation will almost be equal to 10 to the power 8, right? Because there is order of n square and we have nums of length is 10 to the power 4. So just square it, it will be 10 to the power 8, right? So we don't want that. If the nums length is 10 to the power 5, then this code will break, right? What is my hint to? So if we fix one of the numbers, say x, we have to scan the entire array to find the next number y, right? So what we have done is we have fixed this number num2, okay? And we are only traversing nums of I, right? And which is value minus x, where the value is input parameter. Can we change our array somehow so that the search becomes faster, right? So we have changed the array in form of this position, right? What is my hint 3? The second train of thought is without changing the array, we can use additional space somehow, like maybe a hash map to speed up the search. So we have actually used a hash map only, or my dict. It's nothing but hash map, right? So this is how we are gonna do this question. So guys, now let's try maximum subarray sum, right? So it's a medium question, okay, and it is asked in various product-based companies such as Uber, Microsoft, and all those things. Uh, we have given an array nums, okay, and we have to find a subarray with the largest sum and return its sum. So what do you mean by subarray? Subarray is a contiguous non-empty sequence of elements within an array. Okay. So if I say this is my input nums, then my subarray can be, I can start subarray from -3, -4, -1, -2. So this can be my subarray. Okay. Or this can also be my subarray. Right. This can also be my subarray. The only thing is it should be continuous. I cannot select this -2, then 4, then 1, then -5. So I cannot select selected elements. It should be continuous non-empty sequence of elements within an array. Contiguous non-empty sequence of elements within an array, right? So subarray can also take all the elements of this array. This is also a subarray, okay, whose length is equal to the nums of length of nums, right? So let us check nums of length is 10 to the power 5. Uh, so what can be my idea for finding out the maximum subarray? I can initiate with one for loop, right? And what I'll do, I'll just add each and every element to sum. Let's say I have taken sum as the let's say consider sum as 0 as of now. Now what I will do is, after some for loop, my sum will be equal to sum plus nums of I, right? Because I have to calculate the uh, sum of every element of that subarray. Okay, so sum will be equal to sum plus nums of I. So it will get added again and again. Okay, so here I can start the for loop 0 to n. If my I goes up to n, then where will be my j? I don't have j then. So let us make it n minus 1, and my j will be for j in range I plus 1 to n. Let us take these two for loops, and now this is my sum. Now what I want to find out is maximum subarray sum. Find the subarray with largest sum and return its sum. So I need to have something as max sum also, so that I can, you know, calculate. uh, I'll just say it as 0, and I have to update max sum. So max sum is equal to max of, I have to put this operator, max of max sum or this sum, right? Because these are also getting added one by one. Whichever is the highest or the largest, it will get uh, right. It will get stored in max sum. This value out of these two, whichever is the greater, this value will stored here, get stored here, right? Now I think I don't require J as of now. Now, so this will be my idea. So I'll just have to return max sum. So here the output is 6, right? So I have to return max sum, and I don't require this J. Will be equal to nums plus 1 nums. N is equal to len nums. Okay. So there is a trick, guys. This maximum subarray can be solved if I use for loop. Then now there is an algorithm called cadence algorithm. Okay, I'll just write it down. Cadence algorithm. What it says is, whenever the value of sum is less than 0, okay, whenever value of sum is less than 0, then what we need to do, we just have to put sum is equal to 0, right? That is the thing which this algorithm says, right? So Here it will calculate sum, right? And if this sum is less than 0, what it will do? It will return, or it will override the value of sum as 0. And after overwriting, I would say I'll just put this max sum is equal to max of, and my max sum will be getting updated as it is, right? So again it will calculate 0 plus nums of I, right? Yes, this is the logic. So what do we have to do is we just have to put this sum is equal to sum plus nums of I. It will calculate, and we'll calculate the maximum. So let us start iterating and try to understand the dry run. Initially nums of I is -2. Okay, so here my sum is initially 0. So what I should do is I'll take, if I submit it, it is coming correct because the net sum is positive. If my option is negative, then I have to update this to something else. I don't think it will pass all the test cases. Yes. So you can see here 195 out of 210 test cases pass. So if my value of nums is -1, then the sum I'm taking is 0, which it should not. So initially I have to uh, take this value of sum as minimum possible, right? Minimum means it will be negative. So float of minus infinity. Now my answer will be correct. Okay, one more thing is missing. Is it? If my nums is 1, then what? Output is coming 0. Why? If n is equal to 1, just return 1. and if sum is coming less than 0, then my sum is equal to 0 again, then 0 plus nums of I. So 0 plus nums of I is 1. Okay. Then maxim is equal to maxim, that is root of minus infinity and 1. So maxim will be 1, right? Then if sum is less than, n 0 to n, sum is equal to sum is minus infinity. Yes. So what I was doing is, if my nums is 1, then here it is minus infinity. So here only I have to put this if loop. Otherwise this is going very negative, right? So sum is minus infinity. I just have to put that if sum is less than 0, then sum has to be 0. This is Cadence algorithm. And then I can perform that sum plus nums of I and return max of sum. Okay, if I submit this, I think this should work. Okay, if input is nums equals -1, then my output is coming 0. Why? So okay, yes. Okay, okay. Because my sum is -1, so I think this should be on top of if loop. So that I'm returning this maximum. Okay, now this is going wrong. let's say my sum is equal to 0 and my max sum will be float of minus infinity. Now simple what I do is this. Yes. So what I'm doing is I'm taking max sum as minus infinity so that whenever I'm calculating this, I'll I'll have to store the maximum sum as the value. So even if this sum value is coming 0 or negative, it should come or and it should get saved in max sum, right? Yes, I think this should work. Yes. So this is working, guys. Now there are more challenges. So you have understood what is cadence algorithm. It is basically what we are doing is if we are encountering that sum is less than 0, so it is not adding up to our target value, right? So what we are doing is uh, we are basically making the sum as 0 so that it adds up to the uh, max value, right? Total sum. That is the idea. So here you can say that we have taken only one for loop and others are only the assignment or comparison. So the order of these comparison assignment is constant, that is order of 1, and this is where you have the order of n. Okay, so the total time complexity of this algorithm of this program will be order of n, right? So this is how we're going to solve this question, cadence algorithm. It's a new algorithm. You can go and read out anywhere in theory in ChatGPT. You can just search it. They will explain it very nicely. And here also I have explained it what is cadence algorithm, and it is a very helpful approach in finding out the maximum subarray sum, right? With time complexity order of n, right? With time complexity as order of n. Now you can also solve these questions. These are more challenges which are similar to this question. Okay, maximum product subarray, maximum absolute sum of any subarray. Okay, maximize subarray sum after removing all occurrence of one element. So all this will require a lot of brainstorming thinking. Okay, you can just start solving these questions on your own first, and later on you can try looking some hints and you know after each hint you just try it once for 5 to 10 minutes again. Okay, try to implement the hint which is given, right? This will ultimately uh, make your thinking more in that direction, which is helpful for cracking the interviews, right? So that's all guys for today. I'll see you tomorrow same time 11 p.m. Till then, bye and take care.